Well, hello and welcome to this exercise on reciprocal functions or the graphs of reciprocal functions. Ideally, this is an exercise from a past iGCSE additional mathematics exam paper, but I'm not just, I'm going to use this as a revision exercise rather than just answer the questions per se. Okay, so this is the question here, and it says figure 1 shows sketch of the curve with equation 1 is equal to 1 plus c over x plus a, where a and c are integers. And it says find the values of a and b, and the asymptote is x is equal to 3. So that's the asymptote there. That's the vertical asymptote, and y is equal to b, and that's the horizontal asymptote there. Okay. Right, and it then says, next one says, find the values of C and the value of D. So you want to find D there and C from the equation there. Okay, now I'm going to introduce a series of graphs now in the next slide. Right, now for this first set of graphs, now I've got 4 different graphs here, and I should try to explain. Now, note here that compared to the equation in the actual exam question itself, I got 0 there and I got 0 there. So all I've got really is the equation y is equal to 1 over x, essentially. So the vertical axis is x is equal to 0, which is the y-axis, and the horizontal axis, which is y is equal to 0, in other words, the x-axis. Okay, so this is our vertical asymptote from there, and this is our horizontal asymptote. That's y is equal to 0 there for the x-axis. And also note the effect of the numerator. Now, for the blue graph, the numerator is 1, and for the red graph, the numerator is 2. Now, the blue graph, which has the lower of the 2 numerators, approaches the asymptotes much earlier than the red graph, which has got a numerator of 2. Now that happens that happens in both sets of the same graph. Yeah, same thing there. The blue graph, red graph. So the blue graph approaches the asymptotes much earlier than the red graph, and this is because of the value of the numerator or numerators. Now, what I then did was to push my to move the graph, to move the blue and the red graph 1 unit upwards, and I achieved that by putting 1 there instead of 0. So I replaced my 0 there with 1 there. So this 1 now becomes my horizontal asymptote of y is equal to 1, which is there. Okay. My vertical asymptote is still 0. X is equal to 0. That's not changed. Okay. Now for the next set of graphs, now as before, now for the blue and the red graph here, my horizontal asymptote is y is equal to 0. And now I've changed the vertical asymptote to x is equal to 3, because x minus 3 is equal to 0, so x is equal to 3. So my vertical asymptote is now the line x is equal to 3. That's my vertical asymptote. Now the difference between these two graphs here, this one and that one, is that I've shifted the vertical asymptote 3 units to the right hand side. That's what I got there. The horizontal asymptote y is equal to 0 still remains the same for the blue and the red graphs here. And the effect of the numerators is still the same there. Okay. Now, for the green and orange graphs, what I've done is I've changed my horizontal asymptote from 0 to 1. That has the effect of pushing my original graph, this graph here, 1 unit upwards. So that's gone up 1 unit, and that's gone up 1 unit there. And y is equal to 1, which is now our horizontal asymptote. The vertical asymptote is s equal to 3 because x minus 3 is equal to 0 and s equal to 3. Okay. Now I hope all that made some sense. For the next slide, right, now this is the actual question itself. Now we should try and answer the question itself now. Okay, now the first one says find the values of a and b. So you're going to find a and the value of b there. Okay, and it says y is equal to b and x equal to 3. Right, let's see what happens. My answer is a is equal to minus 3, and this is how I got it. It says if the asymptote is 3, equate x plus a is equal to 0, in which case x is equal to minus a, and x is also equal to 3. So minus a is 3, so a is minus 3. So the value of a is minus 3 there. Now we now have to find b there. Now b, this line here, is the vertical asymptote there. And from the last slide, the vertical asymptote will be this number here. So the number there is 1. So this line is line of y is equal to 1. So b is 1. Okay, so b is 1. And if we wish, the coordinates of at the point b there will be 0, 1. Because that's not required. So b is 1. Okay. Now for the next slide, right, we're supposed to find in this slide, the values of c and d. Okay. Now we're told that this graph cuts the x-axis at the point 1, 0 there. Okay. We're also going to find d. Okay, but firstly we need to find c first. We have to be able to find d. So y is equal to 1 plus c over x plus a, and we know that a is minus 3. Okay, and the graph cuts the x-axis at the point 1, 0, so we replace our x there with 1 and replace the y there by 0 there. Okay, if we now subtract 1 from both sides, we end up with minus 1 is equal to c over minus 2. If we then multiply both sides by minus 2, okay, we end up with c is equal to 2. So c there is 2. We now have to find d. Okay, right. Now we know that at this point d, which crosses the y-axis, so the x coordinate is 0 and the y coordinate is d. So we then have that d is equal to 1 plus 2 over x minus 3 because the y coordinate is d as given to us there. So d is equal to 1 plus 2 over x minus 3, and because the point D is on the y-axis, so x has got to be 0 there. So we then have that D is equal to 1 plus 2 over 0 minus 3. Don't forget that C is 2 from there. Okay. So now D is equal to 1 minus 2, 1 minus 2/3. So D has a value of 1/3. And I hope all that made some sense. And oh, that carries about that's 7 marks on there, which is a lot of marks there. I hope all that made some sense. Please subscribe, and thank you for watching. Bye bye now.